Hello everyone, this is Ketish here. In this video, I'm going to go through question number 7 from the AQA 2022 Physics Paper 1 higher tier. This question is on the atomic structure topic on nuclear radiation. Alpha particles, beta particles, and gamma rays are types of nuclear radiation. What does an alpha particle consist of? Now, alpha particle is actually just a helium nucleus. So it should have 2 protons and 2 neutrons. So you could say it consists of 2 protons or 2 neutrons, or you could simply say it's a helium nucleus. Remember, it's a helium nucleus, not an atom. It doesn't have any electrons. Remember, beta, on the other hand, is simply just a fast-moving electron, whereas gamma is simply an electromagnetic wave. 7.2. A krypton nucleus decays into a rubidium nucleus by emitting a beta particle. Complete the nuclear equation for this decay by writing the missing number in each box. Now, nuclear decay equations, very similar to balancing equations in chemistry. Here, the mass number, which is on the top. So, on the top is the atomic mass number. Right, should be balanced on both sides. So you've got 85 plus 0, so that would be 85 there. Now the bottom number is the proton number. Again, that should be balanced. Now here you've got minus 1, so this should be 37. So 37 minus 1 should give you 36. Question 7.3. Internal contamination of the human body means radioactive material is inside the human body. Explain how the risk from internal contamination is different to the risk from external contamination by a source of alpha radiation. Now, if you have it on the skin, then it's external contamination. Inside, if you consume it, then it's internal contamination. Now, alpha particles have the lowest penetrating ability, so it can't even go through a piece of paper. So it's not going to go through your skin to damage anything inside your body if it's on your skin. But if it's already inside, then the risk is way higher. So your answer, alpha radiation has a low penetrating ability. So externally, so if it was externally, alpha radiation is stopped by the skin, so is of low risk. Right? So it's low risk if it's externally, but internally, right, alpha radiation is absorbed by living tissue or by the organs. As alpha radiation is highly ionizing, right, that's your danger. As alpha radiation is highly ionizing, internal contamination will cause greater risk or harm to cells or tissues, organs, or the genes and DNA, which can result in mutation and cause cancer. Now, just a quick note on nuclear decay equations. Remember, you should be able to interpret nuclear decay equations and what happens to the mass and the proton number. So if it was alpha emission, the mass number actually reduces by 4 and the proton number reduces by 2. If it's beta emission, the mass number stays the same and the proton number increases by 1. That brings us to the end of question number 7, and I will see you in question number 8.